Hello everybody, this is Dr. Christopher White and now we're moving on to assignment number 2. So assignment number 2 is a sedimentary rock lab. It's a presentation based lab, so I'm going to be showing you some images of some rocks and we're going to try and classify them. Now I'm obviously not going to tell you the answers, but I'm going to drop several hints along the way which will hopefully make it a little easier for you to classify the rocks. So alright, let's get going. Oh, it'd really help if I hit the right. There we go. We're off. So this is the answer sheet. You're going to find this on D2L. Now I think it's going to be 3 pages long in total. It's a very simple table. So obviously over here on the left, you're going to start by writing the sample number. The rock name will be the final thing you'll write for each sample. Then overall color, whether it's detrital or chemical. Now remember, if it's detrital, it will be made up of pieces of other rocks or minerals. If it's chemical, that means it will either be biological or chemical. So look out for things like pieces of fossil, for instance, or just very, very fine-grained nature. Now, the mineral composition or fossils, I'm going to try my best to point you in the right direction when it comes to that as we work through the presentation. Grain size if crystalline. So if crystalline essentially means if detrital. So if it's detrital, then you can give it a grain size. Now remember, grain sizes: clay, silt, sand, gravel, cobble, boulder. Don't try and give me any kind of size in millimeters. Use those classifications. Once again, clay, silt, sand, cobble, boulder. Oh, did I just forget gravel? I think I did. Let's try that again. Clay, silt, sand, gravel, cobble, boulder. That's the one. All right. And then finally at the end here we have the shape of the grains if detrital. So once again, now keep it simple. Are the grains rounded or are the grains angular? Just keep it to that. Now finally, once you've collected all this information, you will then be able to name your rock. So obviously the question is, how do you name your rock? Well, it just so happens that supplied along with the table, there will be this flowchart. And this flowchart is going to help you in the naming of your rock. It's relatively simple. As you can see, we have the carbonates down here. We have the sandstones down here. We have the mudstones, the silts and the shales over here. We have the breccias and conglomerates here. And then we kind of have the slightly weird outliers over here, the cherts, the dollar stones, coal and peat. Alright, so it's a relatively straightforward flowchart. There's nothing special about it. I don't really need to run through it in too great a detail. We're going to touch on it a little bit as we go through though. Okay, so this is the rock box as you would find it in the classroom. So it's actually just the rocks outlined here in red that would be available to you if we had them. So the first rock in the sequence is 21 and the final rock in the sequence is 36. Okay, so let's talk about rock 21 to start with. So just to give you some idea, by the way, the pieces of rock that we have here will typically be about the size of the palm of your hand. All right. If there are any geologists watching this, the geologists that are watching this are absolutely shocked about the fact that I did not include a scale in these pictures. I was not expecting to use these for teaching purposes. That's why, if anyone's feeling very annoyed at me for that. So anyway, this is about the size of the palm of your hand, just to give you some ideas. So these are going to be rather substantial pieces of rock or mineral. Now what we can see as we zoom into a slightly higher, slightly closer image, we can see we have lots and lots of nice chunks there. Okay, so you have to ask yourself, what size are these? Now clearly this rock is clastic, isn't it? Because we can see the pieces, so that one's relatively easy. So then we have to work out what size of clastic. Clay, silt, sand, gravel, cobble, boulder. Okay, so to start with, have a look through the size classifications and see which one you think would best fit this particular sample. Here's a hint, it's not boulder. So we can see that this sample consists of lots of different coloured minerals. So we have these kind of grey pieces, those are going to be pieces of rock. But then we have, I'm just going to come over here actually, then we have crystals that look like this. Now this is one solid crystal, and if you guys remember from when we did minerals, if the crystal is salmon pink in colour, that typically means it's going to be, and over to you and your notes on that one. So there's one mineral that's very, very obvious in this rock. Now, it's clastic. We know there's one very obvious mineral. Chances are there's going to be another mineral that looks quite glassy when it's in rock, so there's another hint there for you. We know it's detrital. We know it contains a salmon pink mineral and a glassy looking mineral, but it also contains numerous rock fragments as well. So that's very important. In terms of, I'm just going to zip back for a second. In terms of the grain size, well, we can see that the grain size is ranging between these small crystals here, which are quite easily visible. Oh, didn't mean to do that. And these larger crystals here, which are very clearly visible. Now remember, we discussed this already. Silts and clays are not easily seen by the naked eye. Only sands, gravels, cobbles, and boulders are very easy to see. So the fact that these are very, very small clasts, which are visible to the naked eye, should suggest we're at the lower end of those four options. Now, as we come to these slightly larger pieces, well, clearly they're probably a little bit too large for being sand, so maybe there'll be another grain size. Just going to go back. And then finally we have the shape of the grains. What shape are they? Remember, our options are either going to be rounded or angular. Now, it's a bit difficult to see most of the grains because everything's so tightly packed, but I'm going to draw your attention to this corner here. That's, quite a nice right angle corner there. And we have some, nice sharp straight edges here. And you can see this pointy corner here. That's going to kind of give you a bit of a hint about where we might sit. Okay. In terms of when we try and classify this rock, oh, went too far there. So it does not react with acid. And from that point on, you're pretty much on your own. Okay, on to option 22. Or should I say sample 22. Now here's sample 22. Now I want you to ignore these kind of golden spots. You can see them here in slightly greater detail. These are sulfide minerals. They are not important to our classification. All right. I'm also going to tell you that this white mineral here is a mineral called barite. B-A-R-I-T-E. You would never be able to classify it yourself. Now, I'm going to tell you that these rocks here, these fragments of rocks here, which are kind of grey-brown in colour, they will react with hydrochloric acid, but only if the hydrochloric acid is hot. So that's going to give you quite a big hint about what that particular fragment is made from. Now, once again, this sample here is about the same size as the palm of your hand, so it's a reasonably large piece of rock. So this clearly means that these fragments here are going to be quite sizable. So clearly you can work out whether it's going to be detrital or chemical. So we know what the minerals are, and we can see that we have lots and lots of quite, well, I'm not going to say whether it's angular or rounded, but I think you can probably crack that one for yourself. Now, I'm going to be very clear about this. This mineral here is chemical in origin in most cases. However, we're not dealing with this mineral here. We're dealing with the shape of the pieces which have been produced by this rock being broken up. All right, so please bear that in mind. No, that's pretty much it. This one's a relatively easy one. You should be able to crack this one relatively easily. Okay. Now, on to sample 23. Now, to be clear, over here in blue, that is not what we're looking at here. We are looking at this material over here. All right? So, this material is very black in colour, very fine-grained, and you can see it has this slightly shiny appearance to it. All right? Now, if you were to have a sample of this and you were to hold it close to your nose and inhale, you would get a smell that would be like a very weak version of when they're laying asphalt. You know, that kind of slightly hydrocarbony, oily smell you get when you're driving past a crew laying asphalt. That's the kind of smell you would get. Not very strong, but you would be able to just about smell it with this sample. So that's very, very important because that's giving you a very big hint about what this type of rock is. All right. In terms of the rock itself, it's not that strong. It's quite easily broken. In fact, you can see the sample here has these cracks already in it. Okay. In terms of crystals themselves, there's nothing really visible. That, if they are there, they're extremely fine-grained, so we can't see them. Okay, so I'm afraid can't really go too much further on that particular sample without giving away the answer straight away. Oh, it doesn't react with acid. And no fossils are present. Okay, on to 24. Okay, so 24. Let's have a look at it. Well, obviously 24 doesn't react with acid. Let's get that out of the way straight away. So next we are going to try and work out, is it clastic or is it detrital? I think you can crack this one yourselves. Next we're going to have a think about the minerals. Well, once again, just like the sample we saw first of all, it contains lots of pieces of rock to begin with. So all these kind of medium grey and darker grey fragments, those are pieces of rock. So they are going to be made up of multiple minerals, and those minerals are clearly too fine for us to ever see. So we're just going to have to ignore those. Now, in terms of what else we can see if we look around, oh look, there's a slightly salmon pinkish crystal there. Once again, go back to your minerals lab, your notes from that, that's going to give you a hint. And there are also these lighter grey crystals, which we can see quite a few of here. Okay. Now, that mineral would normally look quite glassy. However, because it's been transported around and the surface of it has been roughed up, it's kind of giving it a slightly frosted appearance. So that would give you a slight hint about what that particular mineral might be. In terms of the grain size, we are concerned with the size of these pieces here. Once again, by the way, this piece is going to be about the size of the palm of your hand, or should I say the diameter of the palm of your hand. So we have, once again, some rather substantial little class here. Let's see, in terms of the material that's holding them together, that's the matrix. We're not going to focus on the matrix. We're worried about the size of the clasts. Okay, so please remember that. And in terms of the shapes of the clasts, well, we can see we do have some clasts that have slightly angular corners. I mean, if you look at this piece right here, it does seem to have a slightly angular nature to it. But at the other end of the scale, if we look at this clast down here, it looks quite well rounded. So if you remember when we were talking about clasts, if they're not really angular and they're not really rounded, there's a clast that sits in between. So maybe you want to go maybe you want to think about going there. And then once again, this sample will not react with acid, and that's pretty much all you need to know. I mean, I think it's pretty fair to say that these individual clasts are probably going to be in excess of 2 millimeters. So that's a bit of a hint about your class size there. Now, sample 25 is a bit of a tricky one. Sorry, I'm going to itch your nose. I'm afraid I didn't get a good picture of this one, so I've had to grab some images from Wikipedia, so I'm cheating slightly. So mineral 25 can actually occur, rock 25 can actually occur in a range of different colours, everywhere from a rather dark black browny colour to a kind of medium grey, all the way over to a kind of reddish orangey colour, which is commonly referred to as jasper. Now, this particular mineral does not have any visible crystals. They're far too fine for us to possibly see. In terms of its hardness, it's a very, very hard mineral. Should I say rock? It has a hardness of about 7 on the Mohs scale. When it cracks, it has a habit of producing these very sharp, very jagged edges. So this is a rock you actually have to be quite careful with, because you can cut your hand quite easily. But the most important feature that this rock displays are these things. So if you look at this jasper sample here, you'll see there's this kind of curved line here. We get the same thing here. We get these curved, kind of concave shapes on this piece here. You've got one here and one here. And then we have another set of them here, a few little ones along this back side here. Then we have an edge here where we get one of these curved shapes. We have another shape here. This is commonly referred to as, well, conchoidal fracture. And that's going to help you work out pretty easily what this type of rock is. All right, so have a look at the flow chart, look out for the term conchoidal fracture, and that's pretty much going to guide you straight to the type of rock and what it's made from. On to sample 26. Well, once again, I've nicked some images from Wikipedia because the images I had just didn't turn out anywhere near as nicely. Okay, now when we are looking at this particular image here, we can quite clearly see that this image is made up from pieces of something. Very, very clearly. Now, the person that took this image was a good geologist and actually happened to put a scale on the bottom. So we can see that each one of these represents 1 millimeter. All right. Now, this sample will react with acid vigorously. So that's going to give you some idea about what it's made from. Now, if we just step in and have a look at the close-up image here, you can see it's made of lots and lots of, pieces. If we look here, you can see you've got this kind of rectangular piece and it has these parallel ridges on it. It looks almost like a piece of broken clamshell. All right. If we have a look around here, there's, well, nothing that's particularly clear. Oh, there we go. Some more parallel ridges here. Looks like another piece of clam maybe. This here has a hint maybe of possibly being some kind of gastropod fossil, a sea snail. It's not that easy to tell, I'm going to be honest. I would really like some much more obvious fossils, but unfortunately, gave it away there. But unfortunately, we are not that lucky. So what we appear to have here is lots and lots of pieces of shell. All right, so that would give us some kind of hint about what type of rock this is. I'm just going to take a second just to discuss what we're actually looking at this rock, because this is quite interesting. So one of the things that we need to think about as geologists is, what we can take what we can see when we look at the rock and how we can use that to extrapolate the kinds of conditions in which this rock formed. Now, this rock is obviously made up of lots of pieces of shell, so it is clearly marine. That one's a pretty obvious statement. However, when we look at these pieces of shell, they're very badly broken up. And so this is telling us that these pieces of shell, the organism hasn't just died and the piece of shell has sunk down to the seafloor and been covered in sediment. No. What's happened here is this organism has died, and then the fossil has been quite roughly thrown around for an extended period of time until the shell starts to break down. Now, this is telling us that these shells have been exposed to relatively high energy conditions by a marine standard, and so this would suggest that these particular fossils were located either on a beach or maybe slightly just out to sea, so in very shallow water, close to the coastline. And so what we're seeing here is we're seeing a limestone that's formed from a buildup of shells in quite, in a beach or near beach environment. And we can tell that purely by the fact that these shells have been broken up. And so that tells us something about the energy of the system. All right, so anyway, once again, though, we know this is made of shells. We know it reacts with acid. You can pretty much work it out for yourself. The flow chart is going to lead you to what this one is relatively easily. Remember, as this is a chemical rock, you do not need to worry about grain size, and you do not need to worry about, oh cripes, I've forgotten what the other column was. Let's zip back for a second. You will not have to worry about grain size or the shape of the grains, because this is a chemical rock, so just leave those blank or write NA for not applicable in there. All right, let's keep moving. Okay, sample number 27. Well, as we can see, very fine-grained, can't really see any crystals. Got a kind of grey-brown kind of colour to it. Not really that spectacular in the grand scale of things, no obvious fossils. Now, the one thing that this rock will do is this rock will react with hot acid. So it will react with acid, but the acid must be hot. All right? And so, that's pretty much going to give away instantly what this rock is. 28. Oh, right. Well, 28. Well, because you can quite clearly see we have some more fossils. And we can see these fossils have a rather distinct spiral shape to them. They aren't actually the fossils, by the way. The fossils themselves have been lost. You can just see an imprint of one of them here. What you're seeing here, this spiral shapes, are actually the interior structure of the fossil. So what we have here are gastropod fossils, sea snail fossils. And so what you're seeing here with these spirals is actually sediment filling in the internal chambers of the gastropod fossil. And then the shell itself, well, that's been lost later on. You can also see, if we have a look around, so here we have, once again, here's the gastropod fossil here. Here's one of these internal spirals. If you look over here, you can just see these parallel lines again. That's showing us this is a piece of shell, once again from some kind of clam-like organism. And as everything else, on the other hand, is pretty fine-grained. We can't really see what's going on. It's mostly this very fine, powdery-looking material. So if we put acid on this rock, you will be shocked to discover it will react vigorously with acid. And so it's definitely a chemical rock. We can work out what type of mineral it is by the fact it reacts vigorously with room temperature acid, so you know what this rock is made from. And then the flowchart is pretty much going to take you straight to the answer. It's not a particularly complicated one. Okay, on to sample 29. Right, well, sample 29 is a bit of a tricky one. So when we look at it, we can see it has this kind of, medium grey verging on dark grey colour. It's a pretty unspectacular piece of rock. Now, when I tried to take photographs of this close up in the lab, just didn't happen, so once again I had to nick one from Wikipedia. So what can we see? Well, what you can see is the sample on the whole does look relatively homogeneous, but it also looks slightly grainy. So it's made of, very, very fine particles. So, and those particles are just within the realm of us being able to see them. That's why it has that slightly rough, slightly gritty look to it. Now, if I was to rub my hand over this sample, on the other hand, it would dry out my hand a little bit. Now, this is one of the things that clay and silt-sized rocks have about them. So, a rock that contains clay and silt-sized particles, well, those particles are mostly clays. You might know, if you touch a dry clay, what it will do is it will steal the moisture from your hand. So clays are what we refer to as hydrophilic. They love water. So if they come in contact with it, they're going to nick that water from whatever source they possibly can. So when you put your hand on any kind of rock that contains clay and you rub your finger over it, at the end you're going to take your fingers off, you're going to feel them, and they're actually going to feel quite dry. And so this rock is going to give you that same feeling. If you rub your fingers over it, when you take your fingers off, they're actually going to feel a little bit dry, and that's going to suggest there's clay or silt in this rock. At the same time, this rock also contains particles that are just visible. Remember, clay and silt-sized particles are normally outside the field, the normal field of view of an average human being. So that would suggest that whatever we have here giving it this grainy appearance is a size above a silt. However, at the same time, the fact that when you rub your hand over the rock it's giving it that dry feeling, well, that would suggest there's also clays in there, so there's muds in the rock as well. So what we have here is a rock that seems to essentially have two different types of material in it. In terms of trying to work out what the minerals are for this rock, well, no, we can't work that out very easily. We know it's got clay minerals in there, you could write that, but what type of clay minerals they are, no, we can't work that out. We don't have the technology to do that available to us. As opposed to what's making up the gritty material, well, once again, those crystals are pretty fine-grained, we can't see them, so we don't really have a hope of working out what they are. So, minerals, working out what the minerals are for this sample, meh. Can't really do too much with that. So this one's going to be a bit tricky, but just focus on the fact that it seems to be made of whatever the particles that are ever so slightly coarser than silt, but also there's quite a high clay component to the rock. So just bear that in mind, and that should guide you towards what type of sample this is. Okay. On to sample 30. Alright, sample 30, as you can see, has this beautiful rusty colour to it, and we can see it has these nice layers in there, nice bit of layering. Now, when we zoom in, we can see that this sample clearly looks quite gritty. In fact, I'm going to blow up an image there. There you go. You can see, the individual crystals there quite clearly. Alright, so once again, these crystals are small, but they are visible to the naked eye. So they're not clay or silt. But at the same time, well, I think you can quite clearly see from the picture here, are they cobble, gravel or boulder? Well, you can work that one out for yourself. This piece of rock, once again, the diameter of the picture is about the diameter of your hand. So, try that again, about the diameter of the palm of your hand. So I think it's pretty fair to say, well, you can work out what size these particular clasts are. So, all right, we can also work out pretty easily what the cement is. I mean, this looks like rust, so chances are the cement is iron oxide. In terms of what the crystals are that make up this rock, well, it's pretty difficult to see, but you can get a good hint. So, for instance, if we look at this particular crystal here, we can see it does have a slightly glassy appearance. In fact, if you look around, you can see lots of these kind of whitish crystals here that if you look at them, you know, eye of faith, you can say, yeah, they look like small pieces of glassy like material. And that's going to be a big hint as to what the dominant mineral is in this sample. In terms of the diameter of the class, well, the dimensions of them, you can work that out. We've discussed that already. In terms of the roundness, how angular or rounded they are, well, that one's a bit more tricky. It's pretty difficult to see, and so, you know, you might want to leave that one blank. You might want to say too small, because they are pretty small. So I would understand if you didn't want to have a punt at, you know, whether they were angular or rounded. Okay, doesn't react with acid, by the way. On to sample 31. Sample 31. Sample 31 definitely reacts with acid vigorously. We can see that sample number 31 is very, very fine grained. There's no obvious crystals, and there are no obvious fossils either. Now, if you look carefully, there's a few things here that might be fossils, a few little features there, but I've got to be honest, I didn't take a close enough picture, so I'm not really going to commit either way. So as far as we're concerned, it's fossil free. So it's a fossil free rock that vigorously reacts with acid. Well, we know as it reacts with acid, it's clearly got to be a carbonate mineral. You can work out which carbonate mineral it is. I should point out that's vigorously with room temperature acid, if I didn't say that already. In terms of the hardness for this rock, if we try and scratch it, it's going to give us a hardness of 3. And that's pretty much it for it, to be honest. I mean, the crystals are too small for us to see, but the fact it vigorously reacts with room temperature acid does tell us what mineral it's made from. Okay, on to a fun one. Okay, now if we look at this sample, you can see it has this rather lumpy looking appearance to it, doesn't it? Now, once again, this piece of rock is going to be slightly larger than the palm of your hand. It was a reasonably sized chunk. So if we get in close, you can see once again we have this lumpy look to it. If we really get in close, this is what it looks like. You can see we have lots and lots of particles, and if you look at some of the particles, like this one here for instance, you can see you've got something in the middle of the particle here, and you can see you have a build-up of material around that central particle. So that one's a bit interesting. Same over here, you can see you've got this central particle here, and then you have this build-up of more whitish material over the top of it. So what are we looking at here? Well, I will point out that this sample will vigorously react with room temperature acid. So that's going to give you some idea of what's going on. And for those of you that are still having a little bit of difficulty, this is what these particles would look like if we saw them down a microscope. All right, once again, pinch an image from Wikipedia, so thank you to the geologist that actually took this. But you can see what we have here is we have a central particle, a nucleus, around which we have layers of, well, a mineral that will react with room temperature hydrochloric acid vigorously. So we have a mineral that will react vigorously with room temperature hydrochloric acid here, forming bands around this nucleus. So there's a special term for what these particles are. It begins with O. It's a very satisfying word to say, actually, and you should be able to work out pretty easily what this rock is. So, I'm not really going to go too far into it. Okay, on to sample 33. So sample 33, as you can see over here, is the material that we would have in this red square. This blue material over here, this is just a picture of what lignite looks like. If you remember from the lecture, lignite is pretty low grade coal. It's the kind of coal that when you burn it, it really puts out lots and lots of pollution because it's very impure. Problem with lignite is that it's also the cheapest coal option around. So if you're fueling a coal-fired power station, you tend to end up burning lignite than one of the better quality coals like anthracite, which is more expensive. In terms of what we would see if we were looking at sample 33, well, this is how sample 33 would look if it was in nature. You would have this very brown color, and the material itself would tend to be quite waterlogged, quite boggy, you might say. And if you were to take a piece of this and you were to break it up with your fingers, what you would get is you would get something that looks like this. Looks remarkably like a pretty good quality mulch, doesn't it? So that's going to give you a bit of a hint about what kind of material this is made up of. I'm going to give you a clue. It's not rock. So I think you can probably crack pretty easily what type of rock this is. It doesn't react with acid, and that's about it, really. In terms of sample 34 is a real cracker of a sample, actually. So you can see the sample itself is quite light in colour. And when you look at it more closely, you can quite clearly see it's made of fine particles that you can see with the naked eye. So once again, just to give you an idea of this sample size, it's slightly larger than the palm of your hand. So, you know, these crystals are largest, you can see them, but they're not obviously super large. Now if we zoom in really close, look at that. You can quite clearly see that this sample is pretty much monomineralic. There's only one mineral in there, you know, when it really comes down to it. You can quite clearly see it's made up of numerous individual particles. And you can see these particles have this frosted look to them, don't they? They look like a certain material that has a kind of frosty finish. Now, when we look at the size of these particles, well, you can probably work out what size they are. And in terms of their roundness, well, if we look around, we can see most of them have these, you know, quite round forms to them. There are one or two that do have a slightly pointy edge to them, so they're not all 100% uniform. But, you know, they are pretty rounded on the whole. Doesn't react with acid, by the way. So now we're on to sample 35. Okay, so what have we got with this one? Well, this one is quite a deep grey, and we can see that it does not have any really obvious minerals, so we can't really see anything. It does not react with acid, and the sample itself does have these very, very fine, they're not great, but it does have these very obvious fine layers to them. If you remember, the term for these very fine layers is laminations. So it does have very, very fine laminations in the sample. If you were to rub your hand over the sample, you would get that same dry feeling we got with one of the samples earlier. Now that would suggest there's a certain type of mineral in there in quite large quantities that's nicking the water from your hand and giving it that dry feel. Now, in terms of other things, there's no organic material in this sample, and it's soft. If you try and scratch it with your knife, you can scratch it quite easily. Remember, hard minerals like quartz or silica will not scratch with a knife. Okay, so you can scratch a sample. In fact, if you look over here, you can see there are actually several scratch marks where somebody's gone a little bit mad trying to test the hardness of the rock. In fact, you can see another scratch mark right here. So this is a fine-grained rock made up mostly of a mineral that likes to nick water from your hands when you touch it, and it has these very, very fine laminations in the sample. Now, I think you'll probably be able to work it out from there, but it may be a little challenging, so follow the flowchart carefully, and I think it will take you to the right place. But, you know, if you do have questions about this one, you can obviously ask me during office hours. Once again, I think I mentioned this, but I'm just going to say it again. It does not react with acid. So our final sample is going to be sample 36, and you can see sample 36 has this nice red colour. Now I'm going to be quite clear, so this is not the kind of sample you would normally get in the rock box, but this particular sample was a very nice example of this particular type of rock, so I kind of slotted it in because it just works quite well. Now this piece of rock is very, very large. It's going to be about the size of the palm, not the palm of your hand, your hand in general. So look at your full hand. It was quite a big chunk of rock. So we can quite clearly see that there are no large particles visible. Now when we get in really close, we can see there are some very, very fine specks, but they are pretty much at the limit of your vision. If we get in really close, you can see. Now, this is a bit of a difficult one to call. There's a lot of these very, very fine specks in the rock which are just visible. However, I personally would say that the majority of the rock is made up of material that's too fine to see. Okay. Now, the fact we do have these pieces of other rocks and minerals in the rocks does tell us whether it's clastic or chemical. You can work that one out for yourself. In terms of what the minerals are, well, that one's a little bit difficult for us to say. These pieces are very, very small, and whatever the very fine component of the rock is, that's beyond our field of view using just our naked eye, so we can't really work out what the minerals are. Now, in terms of the size of the fragments, well, that one's kind of over to you, and that's going to affect how you classify this particular rock. If you decide that the majority of the rock is these slightly coarser pieces, well, they are just visible with the naked eye. Most clay and silt sized particles are below visibility with the naked eye. In contrast, if you decide that most of the rock is material that is not visible with the naked eye, well, that means that whatever it's made from is probably just below a sand in terms of its size. So that's going to help to control, how you classify this rock. As you can see, it does have some quite crude layering to it. Not particularly great, but it is there. And the sample will not react with acid. Now, if I was to take this particular sample and I was to actually chew a little piece of it, yes, geologists do actually do that. I mean, we're talking a very, very small piece. If I was to chew it in my mouth, I would create a very, very fine paste. And if I was to rub that paste against the roof of my mouth, it would feel ever so slightly gritty. Okay, now that's going to be important when it comes to classifying this sample using the flowchart. If I just go back to sample 35 for a minute, if I was to take a very, very small piece of sample 35 and chew it and rub the resulting paste against the roof of my mouth, it would feel smooth. Okay, once again, that's going to be important when you classify sample 35. Use it, it's going to turn up in the flowchart. Okay, so those are the samples. I think it's all relatively straightforward. I hope I've covered enough detail for you. Remember, if you do have problems with this particular lab, you can ask me about it during office hours. Remember, check the class syllabus to actually work out where the office hour, when the office hours are. And you can ask me questions about this particular lab during those hours. All right, so I'm going to leave you there. Have a good day, everyone.